So I think we can start the second part right here. We're going to use what we learned for the structured array. We try to give the example about the image contrast. And most importantly, we are going to learn how to adjust. Adjust means change. Can we change the image contrast so we can better see the medical image, or specifically observe the medical image, okay? So right here, if you take a close look, there is a new DICOM file that I provide to you in today's directory. EMI materials underline L5. You will see a new DICOM file, and then the file name is the lung CT. Okay, so it's a little bit different. This is the computed tomography within the lung, okay? Of course, the human lung right here. So the very first step you are going to do, I'm going to ask you to import DICOM header and imaging. So do remember, in the previous weeks, I always ask you to use the DICOM read to get the image matrix, right? But today, I'm going to ask you to use the DICOM info as well, because I'm going to get the information, the header information from the DICOM. Okay, so once you get the info variable on hand, again, you can just observe this variable. You will find out it is actually a structural array with 125 fields. I think now you can understand what does this mean, okay? So anyway, the very first step, just key in these 3 lines. Again, you can skip the notation right here. Just put these 3 lines, the 2nd line, 5th line, and the 8th line. Try to create a new script. Please do not use the command window. Create a new script. Again, you should name it with your student number with a prefix like G or S, right? It will become a part of your homework, so just do it right now. And if you like, you can also use the functions that we just learned, fields. You can try to key in this information in the command window to see what is the fields that we have under this info structure array, okay? I think through this example, you may have the idea it is very important to give a proper name of the variable or even the field. If you simply put like the AAA for the field 1, BBB for the field 2, it will be very, very difficult to understand the meaning or the data meaning for different field, right? So as you can observe right here, we have 125 fields, and actually most of them can be easily read. For example, you can see there is format, there is file size, there is file name field, right? So you can easily understand what does this field represent, okay? Okay, I think this is easy, so all of you can do that. So right now, for the second step, I'm going to ask you to display the image you just get, okay? So just add one more line, the 10th line right here. Again, you are going to use the figure, you are going to use the image show, right? It's pretty similar to what you did before. So you put the image matrix for the very first one, then you use the empty brackets for the second input, and also you assign the border to be type 1, all in string. It is very similar things that we did. So you will get this kind of image on hand. So just check whether you can run this script and whether you can see this figure with the correct image right here. And this is the one of the slides in the chest. This is one of the slides of the CT in the chest. So try to observe it. Okay, now I just want to emphasize another thing right here. I think this is the main topic for the image contrast. So take a look right here. I emphasize this empty bracket, and I put another line right here. I try to show you one important thing. With this kind of the empty bracket, it's actually equivalent to this input. What does that mean? When you put the empty bracket right here, MATLAB will automatically calculate what is the minimum value. You can see the very first input is the mean, right? What is the minimum value of the image matrix? And for the second element within these brackets, you can see this is the maximum value of the image matrix. So that means if you give the empty brackets for the second input, MATLAB will try to access the so-called full range. Full range means start from the minimal value to the maximum value right here. Okay, so this is the same thing. You can simply change your line, change the second input to this one. You will find the same result. You will see the identical image right here because these two things are the same, okay? Just keep in mind these things. This is so-called full range. But I'd like to show you these things. Just take a look on this slide. What we did in the previous slide, we can get a so-called full range window. That means everything I can see include minimal value, minimal pixel value, and also the maximal pixel value. I contain everything, I display everything, so I named it as the full range window. So right now, think about what is window. Window is the range that you are going to display, the range of the pixel intensity that you are going to display. So full range window, that means I will focus on every single value that I can see from minimal to maximum, right? But take a look on the right-hand side. This is so-called long window. Long window means I'm going to focus on the components within long. So just take a look right here. This is a chest image, but I know most of you didn't have the idea about the anatomy. So basically, right here, you can see this is a spinal column right here. This is the ribs, okay? Different ribs right here, okay? Ribs right here. This is the area of the heart, okay? Mostly you can see the large vessels right here. You can see the chambers right here. This is the heart, okay? And these two big things right here, this is the right lobe of the lung, okay? And this part is the left lobe of the lung, okay? And because this is the actual image, so the left and right is actually refers to what we know. So actually, this part is the right side of the patient body. This is the left side of the patient body. Just remember this thing, okay? But as you can see right here, we spend window for all the tissues right here because we cover the minimal value to the maximum value, right? That is sometimes a bad thing because focus is something that we always do. When I say please focus on me, that means I am asking you to ignore your classmates, what they are talking about or what TA is talking about because I say focus on me, right? Now, when I say how about we focus on the lung region? We don't care about the heart. We don't care about the rib. We don't care about any bone or even fat surrounding the rib, okay? We don't care about them. So how about the right-hand side? As you can see right here, in this kind of situation, the heart, the spinal column, even the rib, we can barely see that because now we don't care about them. Now we open the window simply for the lung. So let's compare this part with this part. You will find out that for this lung window, I can easily see the details within the lung, small vessels right here, right? But for this window, because I spent a lot of the window for other tissues, we didn't focus on the lung. So you will find out this area is a little bit dark. That means I cannot see the fine details within here, okay? So this is a difference. When you are using the full range window, that means I try to display everything. But this is not helpful. For a doctor that really want to diagnose the disease within the lung, you need to go for the lung window. That means I'm going to spend the grayscale simply for lung area. So I can see not only the small vessels, I can see the lesion. Actually, this is a lung cancer right here. You can easily see the pleural retraction. So actually, it involves some it's just in front of the contraction to the plural area right here. Okay, so this is so-called the long window. So basically, what we are discussing is so-called contrast. Okay, contrast in Chinese we say 对比. But in English, you can simply think contrast is the way that we can see the detail that we really interested in. For example, long details. So we need to use the contrast optimal for the long, okay? So in order to explain this idea more clearly, what I'm going to do is try to show you this grayscale right here. For example, for the human eyes, we basically can see the dark thing and we can see the most bright things right here. So you can see the black and the white. And between absolute black and absolute white, we can see different gray scales right here. It's more like a ladder. I can see white, less white, less white. I don't know how to say that. It's more like a gray, but we still have the different level of the gray, right? So we say this is a gray scales. But right here, you can just take a look. If you simply use this command line right here, let me show you. If I simply use the command line, I'm going to open this. I'm going to open this one. If I just try to do the things right here, okay, just wait. When you see the busy right here means MetaBase is doing the calculation. Just no worry, just wait. For the very first part, if I just run this part, you will immediately see the info and you will see the image right here, right? But right now you can see this imaging is more like a 500 by 512 by 512, and you can see again this is unsigned integer. Okay, so now what we can do right now, I can simply do the minimal value. I try to understand what is the minimal value of the this image, and I use the get value, but I put in this. If you can remember, you may remember that if you simply put a column within the parentheses, that means everything. Okay, if you don't put the numbers on the left-hand side and right-hand side, you simply use this one. This means everything. So I'm going to calculate the minimal value, everything inside this image matrix. So I will get the minimum value is actually 0. And again, now I can ask, what is the maximum value? You can see the answer is 2,304 right here. So actually, what is the full range? Full range means originally we spend dark to white, black to white. We spend all the grayscale where all the values start from 0 to 2,304. That is what we can see right here. Okay, what we can see right here, this one. This is so-called full range. We consider everything. We spend all the grayscales for all the values. But again, without focus, it may be very difficult to identify small regions within long, okay? Okay, so let's go for the next one. For the next section, I'm going to ask you to do this. What is this? You can see the note right here. I just try to put down rearrange. Oh, I missed another R right here, sorry. Rearrange, A-R-R-A-N-G, rearrange image intensity. To be very honest, there is a special unit called Hounsfield unit for CT. I think this is a professional knowledge that for radiological technology is common sense, but for you, it's a new thing for you. But just do remember, for CT imaging, we do have a special unit right here called Hounsfield unit. That means we need to rescale 0 to 2,304 to a new range. You can see now the new range is pretty like this one, negative 1,024 to positive, 1,280 right here. You can see the range is the same. Okay, the same, but the absolute value is different. So basically, we try to rescale or rearrange the distribution of the image intensity right here. So in order to do so, you need to follow an equation. This equation is, I have to say, this is a fixed equation. If you want to calculate the Hounsfield unit, you need to follow this equation. So basically, how to do this kind of transformation? you need to multiply a so-called slope and add a so-called intercept. Just think about this. It's pretty similar to a linear equation right here. So let me put the equation right here. If I'm going to do the transformation, for example, I do have a line right here. I'm going to transfer the original value to a new y value right here. This is the y, this is the x. I need to follow this linear equation. So think about this. What is the slope? Slope is this one, right? This is the slope. What is the intercept? Intercept is when x equals 0. What is the distance between the line and the original point right here? Okay, so this is the intercept right here. So I have to say this is the equation that you need to follow. You want to do the linear transformation, you need to know, you need to know the slope of this linear equation and also the intercept of this linear equation. And I have to say, where can we access, where can we get this information? You may see, actually, they are all stored within this info structure array. What is these things? Do not forget about this. Actually, you have this on hand. Take a look. After you key in this line, you use the DICOM info to get the necessary information, right? And as we mentioned before, you have 125 fields right here. So basically, you can get this kind of things, okay? Start with info with the period, because now you only have one image, so you don't need to care about one, because even you omit this part, it will simply just get the very first or only image right here, okay? And you need something, just remember this is a specific field. When you are going to do so-called rescale, you want to rearrange the image, right? So you need to start with the rescale. Again, you don't need to finish the whole field name. When you just simply type in the very first characters, you can press the tab key, okay? You will immediately see what is the options right here. So basically, you can find rescale intercept, rescale slope right here. So do remember the linear transformation. You need to use the original value. What is the original value? Image. You need to put the image right here times slope and add the intercept right here. This is a linear equation transformation, linear transformation right here, okay? But do remember one thing. Please put a double right here. Why? As you can see right here, for the very original case right here, it starts by 0, right? And do remember the type right here is unsigned integer. That means you have no way to get negative value, right? Unsigned integer means 0, 1, 2, 3, 4. That is unsigned. With sign, that means you can get a negative value. You need to transfer or convert the original unsigned integer type to double. So we discussed this in the last week. So you need to use the double to transfer the image type, okay? Then you can times the slope and the intercept. So try to do it right now. I think there is a additional line right here. Just try to put in the fourth lines right here. So basically, this line is will help you to transfer or rescale the image value to the Huntsville unit value, okay? So after this transformation, you can simply do the same thing again. You can try to get a minimal value and a maximum value. Okay, you can do that again. Again, I'm just trying to emphasize that you can check the value. After the conversion or rescale, you can check the minimal value and the maximum value right here. So I'm going to show you the results right here. After the transformation, now you can check the minimal value and the maximum value. It will be very different from original 0 and 2000, right? It will become negative 1,000 to positive 1,000 something. If you are interested in the value stored within this field, you can check. For example, info.rescale slope, you can ask. Actually, it is 1. But info.rescale intercept, you can check. It is actually negative 1024. And I have to say this value is generated by the machine, by the CT scanner, actually. Okay, so you should not control the value. You should just get the value because this is generated by the CT scanner, the machine, which machine generates the imaging, okay? But I also want to emphasize if some of you, I know some of you are the graduate students, if you are doing the research for MRI, you don't need to worry about this because MRI, we don't have the Hounsfield unit. Hounsfield unit is specifically for CT, okay? And if you are doing some different medical images analysis, for example, for the PET imaging, we will care about the SUV. This is another story, okay? So for different medical images, we will have different values or units right there. But right now, just think about this. Right now, if we still use the whole grayscales right here, for the minimum value and the maximum value right here, it will still be the full range imaging. We simply change the minimum value and the maximum value right here, but we still spend the whole grayscale right here, right? So basically, it is still the full range imaging. So if we really want to focus on a specific part, we need to think about this. For example, if I really want to focus on the lung, you can see for the full range image right here, lung is pretty dark right here. Okay, that means actually if I want to enhance this dark region right there, I need to do something like this one. I'm going to emphasize the intensity that's related to the lung. I'm going to rescale it because I want to see the details of it, right? So I'm going to rescale the imaging. I'm going to focus on this part. So I'm going to use the minimal value. For example, right here, it can be, let me guess, it may be 0, for example. If this point is 0, this point is minus 1024, I'm going to do this. This is minus or negative 1024, and this is the 0 right here. So I'm going to let the 0 be the white area. For original case, I only see everything that I want to see within the lung to be dark gray or maybe light gray. I cannot see it in detail, right? So I can rescale something like this. I'm going to replace the maximum value to be 0. So everything larger than 0, for example, you may ask me, teacher, I do have some tissues have the Hounsfield unit like around 600. What would happen? I have to say, when you get the value to be 0 or even larger than 0, so I need to put the sign right here, larger than 0 or equal to 0, I will just put everything as the bright color or just the white color right here. So with this kind of the operation, you will see why this part, you can see white. This part, you can see white again. This part, again, you can see pretty white right here. Because now I don't care everything above 0. I set everything above 0 to be white. Okay, I just want to spend the black to white range for the lung. So now I can see the detail within the lung area. Okay, think about this. So this is the way that we operate. We rescale, or specifically, we set up a new window for display. So if we focus on the range for lung, I would say this is the lung window. So how to define a window? You need to remember 2 things. For any window, we will use 2 parameters to define it. The very first one is the center. For example, if this is from 0 to negative 1000, then maybe right here is negative 500. Negative 500 would be the center. So what is the width? More like 512, right? Okay, so you can think, more like the 1024. So a half of the width would be 512. Okay, so width right here, the range you really want to see, and center is the center of the window, okay, right here. So center should be negative 512 specifically. Width should be 1024 right here. Okay. So what you are going to do, I'm asking you to add 2 more lines right here. 2 more lines right here. I'm asking you to set up window center and window width, but I don't want you to do this manually. Again, you can see I want you to access the window center value from the DICOM header. Because this chest imaging is originally obtained to diagnose the lung disease right here. So actually you can access the value. So let's do this right now. You can ask MATLAB again, what is the info? Start with window. You can see we do have the window center, right? Okay, you can ask what is the window center. Again, what is window width? We do have this kind of information saved or stored within this info structure array, okay? But you do see we do have the 2 sets of the value. But I can tell you for the very first set, it's for long window. So what I'm going to ask you to do is just try to access the very first one. So now you can see the first one is -600 for window center and 1200 for the window width. And this is so-called long window, okay? So do it now. So now you can display, again, a new figure. But now just watch out. You need to do something different. You didn't give the minimum value and the maximum value. You try to reset the minimum value. It should be the window center minus a half of the window width, right? Just take a look. What is the minimum value that you are going to use? It should be window center minus a half of the window width, right? So this is the minimum value you are going to set. What is the maximum value? Window center, you add a half the window width right here. This is the maximum value you are going to use, okay? So this is the reason why you put these 2 numbers right here. So try it. If you do it right, you should be able to see the long window image right here. So I think all of you should understand why we put this thing right here, okay? Think about this. This is the way that we can define the display window, okay, based on the window center and the window width. So basically, if you jump to the next slide, you will find out actually more than 1 window we can use. Even they are all from the same image slice, right? Same file. But if I try to switch different window center and window width, this is a 4-range window, right? This is for lung, so I can see the detail of the lung. If I try to switch a window center to 40, window width to 400, actually this is so-called chest soft tissue. This is the way that we can observe the detail for example, heart, or even lymph node, or even some other soft tissue like the face or something. And if you want to really focus on the bone, for example, for the spinal column, or even for the rib, you want to see whether there is a fracture right there, you can switch the window center to 300, window width to 1500. Now you can focus on this detail. Okay, so basically, even they are all from the same image, you switch the window, display window, it can help you to focus on different part of the tissue or different type of the tissue. Okay, so you may find out what you can do right here. I'm going to give you this kind of the list. If you are facing or you are analyzing the CT imaging, we do have the absolute value called HU that we mentioned before. So for lung, actually the window center is around -700 or maybe -600. And for different types of tissues, for bone, we may have different value right here. So this is the reason that why we know which specific center. The very first value right here is the window center. The second value is the window width. If you want to observe the different things right here, you can just simply switch the window center and the window width. And I try to give you this bar. That means this is the specific range that we are going to focus on. So for lung, we focus on pretty low value right here. But for bone actually have a pretty high value, maybe to several hundreds to 1,000. Okay, so you can see if we focus on different things, you will expand, you will use different window right here. Okay, so basically you can try to add in 2 more parts. If I want to see the soft tissue, I can manually assign a new window center and window width, and I can display a new figure right here. So this is so-called soft tissue window. And for bone window, again, I can rewrite or override the window center and the window width to different values right here. You will get so-called bone window right here. So if you finish everything, you should be able to see all 4 figures right here. Okay, so bone window, this is bone window, soft tissue window, long window, and also the full range window right here. You should be able to see all of them. Okay, so this is really important that for medical imaging, choose the right window to display a good image contrast can help you or help doctors to identify the lesions or to observe the anatomy that you or doctor really want to see, okay? This is really important. So because of time, I think I'm going to show you the homework today. So please just borrow me your screen. So I think if you do have this difficulty or you don't type in or key in everything that quickly, you can find this image exercise 05.met file within the directory that I provide to you. Okay, this actually contains everything. I mean, step 1 to step 3, everything that we need. It's all contained in this imaging exercise 05M file. Okay, so basically, if you want to do your homework today, you can simply modify it from this file. Okay, so today's homework, I have to say, is straightforward. I only want you to use a new function. This function is so-called subplot. Please help it. I won't tell you how to use it. I can only tell you to help it. And you will see the usage pretty like this one. But I cannot explain it right now because I want you to help it, to think it by yourself. And what you are going to do is, I don't want to see 4 different figures. Remember, I don't want to see 4 different figures. I want you to display 4 different windows within 1 figure. So now you can see, actually I only have a figure 1. Single figure right here, right? But now I divide this figure into 4 different sub-area right here. This is the function for subplot. Okay, subplot. So now for the very first position, please display the full range window. For second position, display long window. Third, soft tissue window. And the fourth one should be the bone window right here. Okay, so if you can display just 1 figure with 4 different subplots inside, with 4 different windows right here, then you just finished your homework, okay? So basically, I can give you the hint. Get rid of all the figure. Delete all the figures. You should replace figure by subplot right here. By subplot. You don't need figure anymore, okay? Originally, we have figure right here, right? So a quick hint is replace this figure by subplot. But you need to help how to use subplot. If you can replace figure by subplot, you will finish your homework, okay? So do it now. Again, you can discuss with your study group member